Hello, this is Jeffrey Cantwell, and I would like to discuss a bit of history and preservation concerns around the obscure but intriguing audio technology of wire recorders, which is about as dead a media form as you might find among the audiovisual materials at your local archives. First developed in 1898, the magnetic audio format of wire recording typically involves a single device that both records and plays back sound on a stainless steel wire wrapped around a plastic or metal spool. In limited use for its first few decades, wire recording was adopted for military purposes by the US government during World War II and found its greatest period of commercial success in the following years as a compact and portable home recording device and business dictation machine. Yet with the advent of less expensive and higher quality magnetic tape in the 1950s, wire recording rapidly became obsolete. The device depicted here is representative of a mid-century model, one produced by the Webster Chicago Company. I find that even divorced from their function, there's often an aesthetic elegance present in the design elements and materials. But once a spool is fitted into the machine, a steel wire is pulled past a recording head which magnetizes the wire according to the electrical audio signal being supplied, a voice speaking into a microphone, for example. By then pulling the wire across a playback head, the original signal is reproduced. This principle is similar for any magnetic recording such as audio tape or disc. The standard reel is 2.75 inches in diameter and includes 7,200 feet of wire for 1 hour of playing time, with 1 second of recording using 24 inches of wire. Wire recordings were used for dictation, telephone answering services, and other documentary purposes. A greeting or letter could be read aloud and the reel sent to a soldier overseas in order to hear the voices of their loved ones. They were used to capture oral histories and field recordings, as well as home entertainments like music, radio broadcasts, or a baby's first words. Early black boxes in aviation also used the technology. In 1944, Egyptian composer Halim El-Dab used wire recorders to compose music by manipulating recorded sounds, one of the first examples of what would be called musique concrète. In 1949, a Rutgers University student named Paul Braverman brought a small wire recording device into Fuld Hall in Newark, New Jersey, where he captured a 75-minute performance by folk singer Woody Guthrie across 2 spools of wire. Over 60 years later, the badly damaged rolls were shared with the Woody Guthrie archives, where they were restored over several years before being commercially released. It is one of the precious few live recordings of the musician in existence. Wire recording had an edge over wax cylinders or phonograph records in terms of the length of playing time, as well as the reuse of reels, which could be recorded multiple times. The wire itself is a durable material and remained in surprising pockets of operation long after its heyday. For example, an online demonstration of a wire recorder includes a comment from someone who, while serving in the Army of the Soviet Union in the late 1980s, says wire recorders were still being used to capture conversations with other military units, and they were working fine year after year. However, it by no means delivers high-fidelity audio. There are often problems with the recording itself in terms of background noise, as well as more mechanical issues. Recordings are susceptible to physical degradation, as the wire might slip, break, or kink. The recording and playback heads become worn over time, and the motor that spins the reel can become uncalibrated and develop timing irregularities and produce other artifacts that affect the sound. The terms wow and flutter are commonly used to describe the resulting variations in pitch. Because of the nature of their non-commercial use, wire recordings are especially interesting to archivists and historians, as the content captured on the wire is frequently unique. Playing them, however, can be fraught with difficulty. The spools and playback devices should not be made available for general use. Because of the increasing difficulty of finding a wire recorder device in the first place, much less the expertise to maintain and repair them, these recordings should be considered a high priority for reformatting. Before playing back a recording wire, the groove of the playback head can be cleaned using rubbing alcohol on a stiff brush, such as a toothbrush or a cloth. One should confirm that the record and listen switch is in the correct position during playback. Depending on the manufacturer, this labeling may vary. A nylon thread or blank section of wire is usually tied to the end of the wire as a leader, which is attached to the take-up reel. This should be added if not present on the spool. During playback, a head assembly between the reels oscillates up and down to facilitate an even distribution of wire on the take-up reel, which might be recognizable to anyone familiar with a fishing reel. For environmental controls, the ideal temperature should be between 40 and 50 degrees Fahrenheit. Relative humidity should be between 30 and 50%. Any corrosion due to improper storage is a possibility, although rust on the stainless steel wire itself is rare. The main risk from rust is causing the wire to break, which can be repaired. Rust and dirt may also build up on the playback head, which should then be cleaned. For storage enclosures, spools should be removed from their original cardboard containers, which do present a mold risk and offer little protection from moisture. Though there is no general agreement with regard to vertical or horizontal storage orientation, protective plastic containers or archival quality paperboard enclosures are preferred. With regard to handling, despite the wire being about the width of a human hair, they are quite resilient and can be handled directly. One should definitely keep reels away from any other device that might generate an electromagnetic field, and do not leave a spool in the playback device. Another advantage of wire recording over its media format contemporaries is that editing could be performed by simply cutting the wire and tying the ends together, with the knot then being welded or the loose ends trimmed. Because 2 feet of wire equals 1 second of playing time, these splices are often imperceptible to the listener. But these knots can also weaken the wire to the breaking point or cause it to jump the lead and spill out of the device. These spills themselves often require splicing to remedy. My research indicates that an institution will typically reformat the audio into a more contemporary form, and this has been a long-standing practice. For example, a finding aid from the American Philosophical Society Library shows that original recording spools made in 1945 of ceremonial chants and songs of the Onondaga Nation were later sent to the Library of Congress in 1970 in exchange for copies on reel-to-reel tape, and these tapes were eventually digitized. For converting to a CD or MP3, finding a professional digital restoration expert with access to the best available equipment is highly recommended. A modified device that can amplify the signal so it can be recorded acoustically is one solution, or else a customized machine patched directly into another recording device. In most cases, these files should then be treated for noise reduction. Wow and flutter may have been introduced in the initial recording or is audible only in playback due to some incongruity with the device. This could be determined by playing a portion of the reel across multiple devices, although again, simply playing a spool can be damaging. Interesting to note that at least one conservation service states that wire recordings are a nightmare, and that, quote, we do not guarantee that the wire spool will be as pristine as received. During playback, it is actually advised to sit next to the system for the duration, with a finger over the stop button in the event of spillage or other problem. As far as discussion questions, do you own or have you ever encountered obsolete media in a format that is no longer supported? What challenges are there in viewing or accessing this material, and how might they be overcome? For a second question, a pristine playback device for wire recordings can be rare and expensive. How does an institution balance the investment in time and cost against the demands of preservation? Should they decline a donation of certain audiovisual materials if they have no means to access the content themselves? Is third-party preservation and reformatting a consistently viable alternative? What other risks might be involved? The wires could be blank, for example. Any sources I've used for reference are listed here, and thank you for viewing this presentation.